dealing with problems that, where are we? Okay, so these are the ones that the class didn't get to yet, so we'll go ahead and start here. And I think I would like to do the rest of this whole page ideally. So let's jump with this one first off. So what kind of problem is this one?
I want to say probability.
Does it say find the probability?
No. It says how many possible toads are there.
How many possible toads are there? What is that? Anyone? Can remember this?
Wait, is this the permutations?
Yes, permutation combinations counting. This one isn't actually permutations itself, but this is counting. How many? That's counting. Counting comes up to haunt us yet again. But remember, you folks like this. You just got to dust off your brains and remember it. So this is the one where you write down a line for each possible choice you have, and then you put in the number of possible options for each choice. So how many decisions am I making? How many things am I picking?
0.
Well,
6.
yeah, 4 digits and 2 letters. Everybody see that?
Yeah.
4 digits, 2 letters. Figure out what goes in there, and then what do you do with them? Okay, so again, don't forget, letters and digits can be reused. 000AA is valid. So how many options are there for the first letter?
10.
And the next letter?
10.
Or sorry, number, digit.
10.
10, 10, next digit.
10.
Next digit.
10.
Next letter.
26.
Yep, last letter.
26.
What are you going to do with them all?
Multiply.
Multiply them. What did you all get?
6, 7, 6, and then 4 zeros.
Good. Okay, everybody now reminded of these? It's been a while.
Yes.
Okay, let's take a look at the next one. Committee has 5 people selected from 7 men and 5 women. How many ways? So we're picking 5 people out of a total of how many people? 12. Yep.
Is this combinations?
Maybe. How many ways can this committee of 5 people be selected if each member is assigned a different responsibility, or if the members have all the same responsibilities? So Rafe tossed out the idea of permutations and combinations. So remember what a permutation or combination is?
Combination, it's like the one you have all of them and then you have to like put them all over some like the
Yeah, it is the chaos one where you multiply stuff and then divide by other stuff.
yeah.
So the whole concept of it is permutations and combinations, again, are when you're counting, you're finding out how many, but you cannot reuse items.
Mm-hmm.
So I have this pool of people I'm picking from, and I can't pick them twice. I can't say, oh, I have a committee. All right, I'm going to pick Rodessa and Rodessa and Rodessa to be on the committee. You're going to pick 3 different people, right? You cannot reuse items. So the permutation is when order matters. Combination is when order doesn't matter. Now, as you pick them and they're all jumbling around in a big bin, that's combination, chaos, right? That's the C. Permutation, P, is where you pick them and you put them you place them in a particular spot. You're here, you're there, you're there, right? So you have to figure out which of these is which, and hopefully remember how to calculate those.
You said for both.
Oh, yes.
For both permutation and combination, you can't reuse, right?
Correct.
Okay.
Yes, absolutely. That is absolutely true. So are these permutations, combinations? Can you reuse items? Reuse people? No. There's 12 people. You're picking 5 from 12 people. You can kind of ignore the men and the women. I didn't go down to the specifics. I left that section out of the class, so don't worry about that. But which one's which, and then how do you find them? And if you want, you can just use your calculator functions now if you like.
What's a calculator function?
It's math probability, and then you travel down to where it is. So you put in the n, and then, here, I'll show you what I'm talking about. We did it for combinations, we didn't do it for permutations, but it's the same thing. So say I want to have 8 items, I'm picking 4 of them. I put in the 8, and I would do math, go over to probability, and then down to NPR for a permutation, and I want 4 of them, that's NP4. Bam, there it is. So again, you put in your N first, and then you would go to math, probability, and then down to NCR, NPR, whichever one you want. And then after that, you hit enter, and then you put in your R. Okay, so which one's which? Which one's which? Which one and which one does order matter? The first one or the second one? Was that? The first one. The first person picked does this. Second person picked does that. Third person picked does that. So it matters when you get picked. Whereas this one, you're all doing the same thing. It doesn't matter. So this one is the permutation. So how many items do you have? 12 items, right? 7 men and 5 women. And I'm going to pick 5 of them. So you could do it the old-fashioned way, like I did before, where you're picking 5 of them, so you have 5 spots. And then you start with how many people? 12, and then you lose 1, so 11, then 10, then 9, then 8. Done. Or if you wanted to, you could do your calculator, which would be, I have 12, so I'm going to do 12. And I'm going to pick, so math, probability, NPR. How many am I picking? 5. 9, 5, comma, 0, 4, 0. The other one is a combination. So 12C5. So that's exactly the same. The only difference is,
use the NCR on the calculator.
so you start off the same, but because order
It
doesn't matter, it's chaos. So that's when you have to divide up the duplicates. So I'm just going to start on the bottom, and you can start off with 1. 1, 2, 3, 4, 5. There we go. Done. So I'll take my 95040, and I'll divide by
5. No.
5 times 2 is 10, 4 times 3 is 12, so 12, 0.
With 1 each.
So I'm just going to do that because it's easier. But if I wanted to, I could do 12, math, go over to probability, and CR, 5, and there I have it, 792.
Wow, that's so much quicker.
Yep. So I multiply by 120, I get the other one. Is good? All right. So since everybody is coming next class, then we will go ahead and I will mention this stuff though, right? You folks remember the trees? Right, you draw branches, 1 for each option, red, blue, and green. And then it's 2 out of the total for red, 4 out of 11 for blue, and so forth. And then remember, when you draw one and you don't replace it, now you have 1 less marble and 1 less of that color, whichever color you drew. This one, ors, you add the probabilities. Blue then red means the probability of blue. You go along that branch, and then you do the probability of red from there, and you multiply along the branches. And then this one is given. So remember the given?
Oh, it's basically a fraction.
Yeah, okay, actually what it is given this has happened means that if it's green on second, given blue on first, what's probably that blue came first?
Oh, 100%.
100%, because it's given.
Yes.
So just you stand on the blue branch and find the probability that you draw green second. That's it. So just in case something comes up, I want to make sure I mention that. All right.
I just want to double